Hello guys, this is our first meeting. We are going to study about the static electricity. So at the end of my explanations, or during my explanation, there will be a task. I hope that you can do it and you can answer it in the one note sections, in homework sections. So please write down the date, write down the time you do, and the durations of the tasks. Okay, and you put the answer in there so I can check you have done it correctly or not. So this is our learning objective. At the end of this video, I hope that you can do this all questions related to this. Okay, you can read here. Guys, have you ever observed this kind of phenomena? Have you ever struck a balloon to the wall after rubbing it on your head? When you rub a balloon on the head and you put it on the wall, have you ever see that the balloon can stick on the wall? Have you ever have your jumper ever make cracking noise when you took it off? Jumper means that the clothes, okay, your jacket. Have you ever got the electric shock of your doorknob? Maybe you have ever got this, but you didn't what do you call observe it because the shocking maybe very small, yeah. Or but this one, I think all of you have ever seen this. So all things that you have ever experienced, or all things I have already explained before, it's because of the static electricity. Okay guys, before we study, I'm going to ask you to do this simple experiment at home. So please, you prepare a plastic ruler, okay? Don't use the metal one, only the plastic one. Hold one end of the plastic ruler with your hand. Then after that, you rub your ruler with your dry hair, okay? Do this repeatedly in the same directions, okay? Then after that, bring the ruler close to the small pieces of paper, okay? And you will notice what happened to this paper. So after you have done this activity, please answer these two questions in your homework tab. So you can see that the paper is attracted by the plastic ruler because the plastic ruler has charge. Okay, so what is charge? To explain this, to understand it, you have to look at the things that an extremely small scale. So what is that? Yeah, you have to try to understand the things that we cannot even see with the most powerful microscope. So that is atoms. So what is atom? So the atom is everything that we see around us every day is made of atoms. We cannot see individual atoms because they are so small. You can imagine that how is the diameter of an atom is it? Okay, it's extremely small until the microscope cannot read this size. So if the air in your classroom, yeah, there are about, yeah, I don't know how to read this, there are a lot of atoms in here. But atom is already small, right? But we know that atoms still can be divided into three sort of particle. So there is electrons, the negative charge particle, the proton, the positive charge particle, and the last is the neutrons, the one that neutral. So what is inside the atom? We will look at more detail, okay? So the proton and the neutron sit together in a lump in the middle called the nucleus. So in the nucleus contain proton and electrons. Proton and neutron, I mean. So where is the electron? The electrons orbit around the nucleus, a bit like the planet orbiting the sun. So it's like this, okay? So most of the space in the most of the atom is empty space. You can see that in my cursor, yeah? This is the empty space. So if atom were the size of the football field, the nucleus would be a grain of sand in the middle, and the electron would be the orbiting around the edge. So you can imagine how small this is, okay? So I have already told you before, this is the charge of the particle inside the atoms. Okay, or usually when I do it in the classroom, I will draw it simple like this, yeah. So this is the nucleus, right? It's, yeah, there will be a positive one we call as proton. The one that neutral, there's no charge in here, okay? Okay, this is the nucleus, consists of proton and neutrons. And so where is the electron? The electron will be around the nucleus. Okay, so there are two, I should assume that there are two electrons in here. So also electrons. So from the one that I draw, okay, the number of proton is equal to the number of electron. So this one is no charge. Okay, if the number of proton equal with the number of electron, there is no charge. So yeah, this one, yeah, no charge. And how about if it's positive and negative charge? You have to remember one thing, guys. Proton and neutrons never move. Why? Because it's located in the nucleus. There is a strong attractive force that holds the proton and neutrons in that positions. So the one that can move, only electrons. Electron move. Okay? So if electron move, so the negative move, it can create the positive and negative charge. Okay. So how can the atom become positive? Atom become positive ion when it lose electrons. Okay, but atom become negative ion when it's gain electrons. Maybe I can give you the simple example in here. I draw the atom with 2 proton and there are 2 electrons in here. So we can say that this is neutral. Okay, so what happens when this atom lose one electron? One electron go away from this atom. So what happens? The number of protons will be higher than the number of electrons, right? So we can say that the effect is the atom will become positive ion because it has extra 1 proton. Okay, the other example, if I draw the new one, okay, they are the same in the nucleus, and then there are 2 electrons in here, and 1 electron move here or gain, gain. If gain electrons, so what will happen? It means that the atom will get extra 1 electrons. Okay, so if 1 electron is given, then we'll make this atom become negative ion. So one thing that you have to remember is the nucleus never changes or never move. The one that moves is only the electrons. So what will happen if there are 2 charged objects and we move it together? What will be happen? To understand this, maybe you have to flashback your knowledge about the magnet. Okay, we have learned it. If magnet, if they have the same pole, yeah, the north with the north, they will repel. They will repel. Okay, but if you put it with a different pole, like the north and the pole, they will, the north and the south, they will attract. Okay, so same with the with the static electricity. So the opposite charge will attract, okay, but the like charge or the same charge will repel. Okay, so this is exactly the same things with the charge. Okay, so if there are 2 positive charge, then you put it together. Okay, I draw it positive, yeah, positive and positive, they will repel each other. There will be a repulsion force between them. Okay, and same with the negative and negative, they also will repel because there is a repulsion force. You can try to practice this at home by using the two pieces of ruler. So there are two rulers in here, two ruler. Then you have already rub it. You hang it with the ropes, right? And you also do the same thing with the ruler, with the other ruler. I mean, you hang it with the ropes and try to move it closer. Then you will see that there is a force that separate them. They will never attract each other. They will always repel each other, because we know that these two rulers having the same charge, yeah, or negative charge and negative charge. Okay, so how about if positive and negative? If positive and negative, there will be an attraction force between them. Okay, see that they attract. Yeah. So how about if the charged object with the neutral one? So the charge will attract the neutral object. Yeah, neutral. There will be an attraction. The negative one also, there will be an attraction with the neutral one. Okay. So the static electricity can be caused by when there is a material that are rubbed against each other. Okay. So the electrons, when you rub the materials, so the electron can move to one another. Okay, so if the materials get the extra electrons, okay, this is the materials, yeah, it get the extra electrons, or it gain the electron, then it's become negatively charged. Okay, but if the material has lost, yeah, you see my arrow, it lost, go away, then it will become positively charged. Now you can see the simple animations about yeah, maybe the same experiment that you have done. If the last one I asked you use the ruler, you can use the balloon also. So when we rub the balloon, okay, with our hair, okay, you can see that our balloon can attract the hair. Why? Because they have the opposite charge. Okay, you can see the more detailed animations. So when you rub it, then you can see that. So as you can see that when I rub the balloon onto the hair, so there are some electrons that move to the balloon. Okay, so when the electrons move to the balloon, then the balloon will gain electrons. So we can say that when it gains the electron, okay, it becomes negatively charged object. Okay, then you can see here the hair, yeah, lose the electrons. There are some electrons that move to the balloon. Okay, so when the hair lose the electrons, the hair become positively charged object, yeah, positive. The balloon become negatively charged object. Then they have the different charge, so they will attract each other. So you can see that actually static electricity is caused by the imbalance of positive and negative charge. Yeah, this one that cause the balloon can stick to the wall. Okay, why the balloon can stick to the wall? The wall is neutral actually. Okay, so when you rub the balloon into your hair, then your hair transferring the electrons into the balloon. So when the effect is the balloon gain the electrons from your hair, so the balloon become negatively charged because gain electrons. Okay, so the negatively charged balloon will cause or will attract the neutral object. Yeah, the neutral object. So wall is neutral. Okay, same with the, yeah, when your hair to stand on end when you brush your hair on a dry day. Okay, I think you have ever, yeah, when you comb your hair, then you will see that your hair is standing. It's very difficult to tidy or to make it more neatly. Okay, so you can sometimes you can feel the electric shock uh, when you get from the metal door handle. So lightning also one of the example of static electricity. So where the lightning come from? Okay, what caused the lightning? So actually lightning is just a static electricity, but it's very large scale, very huge. You can imagine that how much the energy that's stored in the lightning. So it can damage the building, it can burn anything that has been struck by the lightning. Okay, so what caused the lightning? It's because of the rubbing between the air molecule around the sky. So we know that when the water evaporate, right, the air molecule will go to the sky, and they are moving with a very fast speed. Okay, so when they move, and they will collect into the clouds, right? So there will be a possibility for them to have a rubbing each other. So it makes in the thunder cloud, yeah, in the cloud, yeah, thunder cloud, the bottom is usually the negative one, and the top is positive one. So when the lightning flash happen, yeah, it hits the air to the temperature 5 times hotter than the surface of the sun. Oh, amazing, 5 times hotter. That's why the lightning can damage anything. Yeah. So, so this caused nearby air to expand and vibrate, forming the sound that we hear as the thunder. So this all is the interesting facts about the lightning. You can read it now. So you can see that there are a lot of energy in the lightning. So can you imagine that? Is there any possibility for us to use a huge energy from the lightning? So is there any advantages or the disadvantages of using that kind of energy? I think right now we still haven't found any kind of applications of the energy from the lightning. Okay, now this is some myths about the lightning. Okay, so I think every day maybe our house also or our building also has been struck by the lightning. But why we don't get burned by the lightning? Because every house or the high building, they must have a systems that protect the lightning from the lightning. I mean, we call as the lightning rod. Okay, so and there's no other way to prevent the building from the lightning. You only use the lightning rod. Then we will study in our next lessons how the lightning rods work. So now we are going to discuss what is the difference between the conductor and insulator. Okay, uh, in electricity, okay, not in the heat. Actually, they have the same term, right? But different definitions. So the definition of conductor in electricity, it means that the electricity can pass through that object. Okay, if insulator, the electricity cannot pass. Okay, so why an object can be the insulator or can be the conductor? Okay, so an object becomes the insulator because the electrons are bound firmly to their atom. Okay, there are a lot of attractive force that bond the electrons, so the electron cannot move easily in there. Okay, so if conductor, there are a lot of free electrons, or you can say that the electron can move freely. So that's why when the electron can move freely, so the electron can go from one place to another place. So the electrons can bring the electricity from one place to another place. So only the insulator that you can charge by rubbing. For example, with the experiment you have done before, when you rub the ruler is the insulator. Okay, when you rub it, so you give a force, a friction that move the electrons from the ruler or from the balloon. Okay, but if conductor, you cannot rub it, because if you rub it, the electron is freely to move. Okay, then it will be easily to lose the electrons. So if you rub it, the electron go away, but your body, okay, or the ground can transfer the electrons and neutralize the conductor. So now we are going to discuss about how big the force, okay, how large the force from two charged objects. So this question has already investigated by the Charles Augustin Coulomb in around this year. Okay, this is here his lifespan. Okay, so he said after he do the several experiment to compare the relations between the charge and the relation between the distance with the force, okay, he said that the electric force between two charged objects is directly, ya, berbanding lurus, directly proportional to the product of quantity of charge on the object, and inversely, berbanding terbalik, ya, to the square. Okay, but remember, don't forget the square. My experience, it's very often for the student to forget to put the square in here, so I circle it. Yeah, you don't forget this. If you forget this, then your calculation will be wrong. Okay, so this is the formula that's stated by the columns. So what is the K? Okay, K is the constant. Okay, so we can give the name as the Coulomb's law constant. Okay, so the value of this constant is depend on the medium that the charged object are immersed in. So we assume that every charged object is in the air, like us right now in the air. So the value that we use in our next calculation is 9 times 10 to the power of 9 Newton meter square per coulomb square. So remember the formula to calculate the force from two charged objects. So the F is equal to K times Q1 times Q2 per, you can use D or you can use R. Some will use R and it's okay. Okay, but just remember it must be in square. Okay, so the K is the constant. We have already discussed this. So what is the unit for the Q? Q is the electric charge. Okay, you can use the capital or small letter. So some book use the small letter, some book use the capital letter. So the unit for electric charge is coulomb. Yeah, coulomb. Don't forget. So 1 coulomb is equal to 6.25 times 10 to the power of 18 electrons or proton. So wow, it's very huge, right? So the charge of 1 electron or 1 proton is 1.6 times 10 to the power of negative 19 coulomb. So how do you get this? You just divide it, right? Okay, 1 divided by this, you can get this answer. And remember, yeah, the distance must be in meter. So if your teacher give you in centi, so don't forget to convert into meter. This is the most common mistake. Most of the students forget to convert the units. They let the centimeter in there. Then you will not get the correct answer because the force must be in newtons, and you know that newton is the SI unit for the force. So every quantities or every number that you use in here must use the SI unit. Okay, then the F can be positive and negative, because if the F positive, it means that the Q is positive and positive, or negative and negative. Q have the same charge. If the Q have the same charge, then they repel. That's why if you get the F is in the positive charge, F in the positive result, then it's the same charge, repulsive. But if you get the negative force, it's attractive, because the Q, if negative and positive, so they attract. If attracts, the F will be negative. Okay, now we are going to discuss this example. Okay, suppose that there are 2 point charge, each with a charge of 1 coulomb. Yeah, so I can draw. Usually drawing is more clear. Okay, so there are 2 point charge, right? Each with a charge of plus 1 coulomb. This one also plus 1 coulomb, all separated by the distance of 1 meter. 1 meter. Determine the magnitude of the electric force of repulsion between them, because they are having the same charge, so they will repel. Yeah, there will be a repulsions, and the repulsions will be equally same from the first object or the second object, they will have the equally or identical repulsion force. Okay. How to count it? Just put into the formula F equal to K times Q1 times Q2 per R square. So luckily this question have the SI unit already, so you don't need to make a conversion again. So 9, the K, don't forget the K. Usually the K is given in the questions, but if the K is not given, you have to memorize it. 9 times 10 to the power of 9 times the Q1 is 1 column times 1 column again, divide by R square. R square is 1 meter square. Wow, there's no any conversion in here. All is already in the same SI units. So the answer will be 9 times 10 to the power of 9 newtons. Okay, another example, the more advanced one. Usually when the charge, they don't use the coulomb, but the charge in the micro coulomb. So you have to convert it into coulomb. Okay, so if the charge is 3 micro coulomb, will be equal with 3 times 10 to the power of negative 6 coulomb. Okay, and don't forget also the distance must be in meter. Okay, so 15 centimeters become 15 per 100. Yeah, 15 per 100 or 0.15 meter. Okay, so let's do it. So F equal to K times Q1 times Q2 per R square. The K is 9 times 10 to the power of 9. Okay, Q1 is the negative 3 micro coulomb, so don't forget to change it into coulomb, times 10 to the power of negative 6 times 5, also times 10 to the power of negative 6, okay, over the R. Yeah, the R is 0.15, or I can write down become 0.15 square. Okay, how to solve this? I think you will learn this in mathematics, how to solve the exponent questions. So we just rewrite it. 9 times 3 times 5 times, if in power, I will explain a little bit about mathematics. So a times n, times a times m, same number, will be a to the power of n plus m. Don't forget with this. So in this case, I can write down 10 to the power of 9, right? I added my negative 6 and also with negative 6 over 15 per 100 times 15 per 100. Okay, so the answer is so I can cross the 3 times 15, 3 times 5. 3 times 5 is 15, so can be crossed with this one. Okay, so 15 with 3, I can cross this. I divide by 3, so become 3 and 5. Okay, so the result is 3 times times 10 to the power of 9 minus 3 minus 6 minus 6 again, so minus 3 over 5 per 10,000, right? 10,000. So will be equal with 3 times 10 to the power of negative 3 times 10,000 per 5. So the answer is 3 per 5 times 10 to the power of negative 3. I change this into 10 to the power of 4. Yeah, because there are 4 zeros. 1, 2, 3, 4. So the final answer will be, so I write here, okay? 3.5 is 0.6, right? Times 10, right? So the answer is 6 Newton. So how about if one of the charge decrease into 1/3 from before? Or we can say that the Q is 1/3 from the Q before, or Q1. Okay, so how to do this? You have two options. Okay, to do the first one is you count the new Q, and then after that you do like the number A. But I don't suggest you because it's longer. I prefer to use the ratio. So I can use F1 compared to F2 equal to K times Q1 times Q2 per R square compared to K times Q1 times Q2 again per R square. And you see these questions, the force is the same. Ask you the new force, right? There are two objects, okay, and this is still like before the Q. This one is 1/3 from the previous one, from the Q. Maybe don't say Q1 because later you confuse. From the Q, yeah, previous. Okay, previous. Okay, so they are having the same K, so you can cancel it, right? Okay, so we assume that the Q1 is the same, still stay the same. So Q1 times Q2, okay. The one that changed, yeah, this is the one that for initial. This one after. So Q1 still the same, nothing changed. The one that changed is Q2, yeah, Q2, yeah. We assume that the one that changed is the Q2. Okay, so Q2 become 1/3 from the last one, from the previous one. The R, same or not? The distance is the same. Okay, so we can cancel. So we get F1 to F2 will be, yeah, the Q1 is the same, we can cancel it. Q2 also you can cancel it. So 1 over 1/3. Then you can simplify this by multiply all by 3, so become 3 to 1. Or we can say that the F2, yeah, equal to, yeah, 1/3 from F1. Okay, so if the last one is 6 newtons, right? So 1/3 from 6 newton, then the answer is 2 newton. If you're still confused with this, maybe I can rewrite this as before, yeah. Initial. So there are two objects, okay. Q1, Q2, yeah. Then they experience because negative, right? Negative, so they should repel. Oh yeah, at the before I don't write down the negative sign. It's okay, yeah, because if you can you can understand the question. They are having the same the different charge, so they must attract. So attracts, so the F is negative. But if you don't put the negative, for me it's okay. Yeah, this is before, right? Then after, then change become after. So still have the same distance, yeah, Q1. So the first one is, yeah, other keep the same. So we assume that the one that changes is the Q2. This one. So this one become 1/3 Q2. Okay. Okay. Then from this one, you have to find the F2. This one F1. Okay, that's for the B1. Okay. Now for the C1. The C1, ask the new distance. Okay. The other one keep the same. So I can write like this: initial, right? There are Q1 and then Q2, attractive, right? F. Okay. After that, there are two. The Q still the same, Q1, Q2, but the F become 9 F. So how much the new R? R1. What is R2? Yeah, I still prefer use this one. So F1 to F2 equal to K times Q1 times Q2 per R1 square to K times Q1 times Q2 per R2 square. I can cross the K. The Q, I can cross it because still the same. Keep the same in this case, yeah. Keep the same. Keep the same. But the F1 is, this one is F. This one is 9F. Equal to 1 over R1 square to 1 over R2 square. Okay, you can cancel the F. So it becomes 1 to 9 equal to, you can do the cross multiplication, you get R2 square to R1 square. Okay, so how to get the R2 and R1? You can use the roots in here. Roots 1 to roots 9 equal to R2 to R1. Okay, so 1, 2, 3, R2 to R1. So I can say that, sorry, R2 to R1. So in this case, yeah, to increase the force, so the R2 must be 1 per 3 from R1. So my drawing is inaccurate because if you want to get the bigger force, yeah, this one larger, this must be smaller. Yeah, remember, inversely proportional. Okay, so after you do, I suggest you to check, use your understanding. If you want to get the bigger force, then the distance must be smaller. If the distance bigger, then the force will be smaller because force and distance is inversely proportional. Okay. If you're confused with this part, you can change into fractions. Okay, become 1 per 3 equal to, yeah, R2 per R2 per R1. Okay, so R2 cross multiplication equal to 1 per 3 R1. So guys, if you're confused in the first time, it's okay. So don't give up. Okay, the best way to understand this is practice, because practice makes perfect. So please try to do these questions in your homework tab. Okay, if you feel difficult to type, then you can do it in the piece of paper. After that, take photo and paste it in your homework tab. Okay, so I can check you understand or not. Then I hope that tomorrow I can see your working, so I can know that you can or not. Keep study so we can discuss again next time. You also can find another questions in this website. Okay, you can try to do it there, and there is a key answer also to check your answer is correct or not. And you also can search this kind of question from other place, and I will help you, and I will discuss. If you have a problem, just feel free to ask and contact me anytime, and see you again next time, guys.